That's the one question you're likely to encounter during the exam. That is request and limit. So it should be easy. Let me show you. All you need to do just apply the resources with the limit and request, then you should be move on, right? Easy. Now let's check if we get it right. Oh shoot, why we have the pending part? We're probably gonna fail this question, right? I think so. Well, when you're in the exam, you don't want to be that guy to troubleshoot that pending part. There are 3 traps that you need to avoid during the exam. I'm going to help you to solve those traps. So the fast way to solve this request and limit question, the first step is to modify the deployment. Edit, deployment, namespace, production, and WordPress. The resources block sit under the container at the same intent level as image, not under the spec, not under the container. Under the resources, what we're gonna change it? In this moment, we need to check the documentation. Click on the documentation and just type resources management. It should be pop up as the first one, and then you're gonna search kind, and then you should be land on this. Now you can see the request and limit is there. So what you do, you're gonna copy the request and limit, go back to your question. Now you're going to put that underneath it. You need to be careful with the indentation. This one should be here. The limit should be the same level as the request. So the CPU and memory also need to be indented properly. Now you may have questioned, how do I change those values? In fact, that's actually a calculation how to do that. Now go back to the terminal. First of all, we need to inspect the node so that we know how many CPU and memory we're gonna have. We're gonna do k describe node 01, because in here it pointing Pacific node 01. That's why I know why this is node 01. So here's the trap that caught me, and it's going to catch a lot of people on a CKA exam if you are rushing. The question usually says split the node capacity evenly across 3 parts. So your brain is immediately think division, right? It's actually a 3-step subtraction problem. If you get it wrong, your part is going to be stuck and pending. So step 1, read the node. Allocatable show 1 CPU and 1.8 KB. So under the exam pressure, you cannot pull out your calculator and do the calculation, right? And don't try to do it on your head as well. I'm going to show you how to calculate that in the terminal. So copy this number, and then we're going to do this command and divide 1024. That gives us roughly 1800 megabyte. And this exact spot is where I messed up. This is the track 1. I directly divide 1800 by 3, set 600 megabyte per port, and call it a day. Don't do that, because allocatable is just what the nodes physically has. It's not what is free. Step 2, scroll down. Selenium is taking like 100 millicore and 10 megabyte. So you have to subtract that what's already scheduled. Now we're gonna take the 1803 and then subtract 10. So that leaves us 1793 megabyte of actual free space. The schedulers only care about this second number actually. Now step 3, we need to divide this by 3 because we have 3 replica, right? So we're gonna do the same thing, 1793 and divide it by 3. That's gonna give us 597. But don't push it to the exact edge. Ran down to 152 megabyte because that leaves about 250 megabyte. I usually leave some breathing room so other program and kubelet can actually work properly. So 512 is actually a good number. The CPU is actually way simpler because one CPU equal 1000 millicore. Because the Selenium is actually taking 100 millicore. That's why we need to subtract the Selenium. 1000 minus 100, that's going to be lead me to 900 millicore. We are going to divide 900 by 3. So the bottom line is let the terminal do the math and then leave some slack. Number 2, syntax trap. And every number in this YAML file is a trap waiting to happen. If you type 300 without the M, it assumes you want 300 whole CPU core. Good luck finding a node that big. And the event log just say insufficient CPU. Always add the M and use 0.3 if you prefer decimal. Memory is even meaner. If you type plain 512 without a unit, so Kubernetes is gonna think this is 512 byte. That's less than a single kilobyte. What you want is 512 MI with a capital M and a lowercase I. And match the 1024 base numbers the node that give us. If you set the request, don't forget to set the limit as well. So it's gonna 3512, and they have to be exactly equal. That's what put the pod in a guaranteed QoS, which is what the question is actually asking for. So it's 512 MI for both. Trap number 3, the init container trap. This pod has two containers, an init container and the main container. To get the guaranteed class, every single container in the pod must have matching limits and requests. If you size the main container perfectly but forgot the init container, Kubernetes quietly drop your pod to burstable. You're not gonna find any error, you just lose the point. So right now we also need to account for the init container as well. And I'm gonna put it here. Now you may wonder, if both container asks for 300 milliquart, does the pod need 600? No, init container run before the main container, not at the same time. The scheduler takes the larger of the two, not the sum. Matching the number costs you 0 extra node capacity. Now I think this is done. Let's apply it and check. Now let's verify our work. All 3 pods are running and all 3 are guaranteed. And let's be clear, guarantee is not just a label. It's your receipt. It's Kubernetes confirming that every container has a matching request and limit. If even one pod came back burstable, you instantly know that a value didn't line up or a block was missing. It's an automatic checksum. For the second check, let's go back to the node. Look at the allocate resources. Our CPU request went from 10% all the way to 100%. That extra 900 milliquart is our 3 pods running at 300 each. The unclaimed capacity is fully utilized, and there's no board stuck in pending. Right, that's the whole pipeline. Subtract existing workloads, watch your units, match your limit, and use this quiet node to verify your math. See you next one.